So I begin now. So my name is Maximilian, and I will present you part of my work. In my PhD is about time-traveling debuggers, and during my thesis work, I have worked in several libraries. But first, I would like you to introduce my application to count horses in my farm, which I don't have, but I will someday. Because horses are cooler than sheep, so everybody knows that. Okay, so now go back to my work. So yes, let's go immediately to the demonstrations. The first thing that I want to show is what I call language extensions. And I don't know if you can read, but it's okay. You can, everything of what I am showing here is in a repository. You can directly install from a baseline. So language extensions, why? When I arrived or when I started the PhD, I came from an engineering background. I had experience with other languages, and then I was introduced to Smalltalk and Faro, and I was missing a lot of, I don't know, operators or things that you don't find in Faro. So my first challenge was, I was told that Faro was really cool. And so I did not see that at that point, so I missed the operators, so I started to create my own operators. So, for example, okay, I know you will not like this, the switch case implementation, because I noticed, and actually in Faro 9 there is an implementation of that, but I think no one uses it because the debugging is terrible. And also there is the philosophy that it is better to do more objects, more classes, rather than a branching. But in any case, in my experience, when I was playing around in the playground, just to prototype stuff, I don't want to create like 5 classes just to have like a conditional with, yes, like dictionary, or maybe, yes. This is clean. In my opinion, the notation that I how to say, I managed to get in the end is clean, is, you can debug it easily. I mean, if you want to play around with that, you have a switch case that you might like. Don't use it in your code. It's preferred classes, as we all know. Then the second thing that I was missing is I used to utilize Python. And they have this unpacking operator, or yesterday it was called the collection something. Deconstructor, right, exactly. So I implemented my own version of that. It's not by modifying the compiler. It's just by using reflection, and of course, I imagine it has a cost to pay of performance or whatever. So this, if you're not familiar with and I would call it the unpackaging operator. So you have the variables defined, then you give the list of the variables, and you directly assign, you make like assignment to each one of those. So in this case, A will be equal 1, 2, 3, and you can put like nil because you don't want to save the second variable. I don't know if you know how it works, but you have that operator there. If you want to use it, it's ready to use using reflection, so it works. And second, and lastly, in that regard, I really miss that operator, the plus equal something. I really miss that. So in my opinion, it was also a challenge for me. How can I implement that? And also, I did it also using black magic, also known as reflection. So it works, and you can use it. No, it's just black magic. Reflection, just reflections. I don't know how to do that, so that was the challenge. So in the end, yes, Faro turned out to be good, Smalltalk, so good for Faro. So secondly, yes, the class called, no, maybe I will do the Autotype, yes. Maybe I will not be able to show everything. So in my work, I work with queries. The problem with queries is that sometimes we need to collect results, and in the collection part, I always use dictionaries to create like some sort of new, I don't know, like meaningful result. But I will get to that. Autotype, what it does, it creates, in runtime, it compiles a new class for you based on the setters that you're used. So you can create data structures on the fly. So in this case, yes, this is red because this is a variable that is not declared here. But once we run that, that will be fixed. And this is red because that message doesn't exist in the system. This other also. And what I am doing here, I am creating a person of a class that doesn't exist that will be generated that has a member called or a variable with setter and getter called first name, last name, and some random data. So when we run that and you inspect, you get an anonymous class, which is a class that it's not installed in the system, but it has everything like instance variables with, well, again, the setter. So we have the full name. We have full name, right? No, well, some random data. But the thing is that when we run this new class was compiled, the methods are recognized, so we can use this new data instead of dictionaries, which in my opinion is better. It's more object-oriented, at least, more elegant. And okay, to get to the point why I did this, so we have the demonstration number 2. When I use queries, there is always the collect expression that the results is, you can think of the results of a query as a table. And normally those tables have different columns. And each one of these lines, so to speak, represents one column of that rows. So initially, if I wanted a really object-oriented solution, so I started to create one class per query, one class of result type per query. At some point, I have 20 queries. I have to create those 20 results. And then if I change something, I had to change everything, so it was a mess. So using this new, how to say, the Autotype tool that I made, I just create the collection, I define the class in the collection expression, just so I don't need to actually create that class. So if you take a look here, every item is of the type that you are creating. And again, with the same input data. The input data, by the way, is just a normal array with just it like that. And you can create like new objects when you are collecting the data. That is essentially the point. So my advice, if you work with queries, you might want to take a look at this. This exists in other languages, and at least .NET and in Python. So if you already know those languages, this will be easy to understand. Yep. But
now, what's happening to self-class?
Yes, self-class. Well, two things. So we can. No, this not. Yeah, wait. Okay. No. First. Okay. So I create, it's always a name class like this. But since it's not installed in the system, I can create several classes called like that. That's all. But you cannot browse it, so that is one problem. Self-browse. Well, not that. I don't know what happened, but yes, this is what you get, just because it is not registered. It's not registered in the logs also, so you can run that and not go on performance overhead.
So just, is it called Autotype in Python too?
No.
I would call it flyweight class.
Yes, I mean, I random name just to make it work.
Okay, because
So,
I was thinking that this was about typing,
yeah, yes. The name comes because in other languages, not everything is an object. So I cannot call auto class because just in my head. An integer, it was not a class at that point. Whatever. And how much time do you have? Okay, so we will be able. So the last example is called QuickWrap. So also during my thesis, I have several times I wanted to instrument method with code to see what they were doing, to log stuff. And at some point, I discovered meta links and method proxies, but they are difficult to use. So what I came up with another idea to instrument these methods, and this is what I will try to show now. So I have a class here called myRepeater with only one method. It is repeat. And just for debug purpose or for showing to you, it will log in the transcript whatever it is receiving, and it will return the same object. So I will show that now. I already have this. So if we execute this, we are just logging that. I hope you can read, otherwise it will be embarrassing. So how to use it? Then I will try to explain what it does. So what I am doing here is using a pragma in my function. The pragma is saying that I want to grab this method with a method defined in this other class, the class side, that has this selector. And this method is actually going to receive, what this method does is just rounds the content of the original method in parentheses. This is the definition, but it's not important. I want to show that what the output does. Well, didn't work. Great. This, I'm thinking why this doesn't work. Is you what? Well, okay, I guess you're really nice. Yeah. So that was the idea. I hope that it was a nice idea. Just things happen.